this video, we are going to look at the instantaneous rate of change. This is a change that takes place over an instant or a specific point in time. For example, the speed that you see on the speedometer of a car would be an instantaneous rate of change. This deals with only one point on the curve. A tangent line is a line that touches a curve only at one point, as shown here. P is called then the point of tangency. Consider estimating the slope of the graph of the function y equals x squared at a specific point 2 and 4. We are looking at this point here. Now we can take 2 points and form a secant. For example, if we took the point at 0, 0, then we could find the slope of the secant line here. But we want to make this a lot more accurate than just taking the slope of a secant line. To make it accurate, we want to move our point Q closer and closer and closer to P. What we want to do is take a point that is very, very close to P on either side of P. We're going to take one point on either side of P. For example, then, we could take the point at Q at 2.01. So 2.01 is really, really close to 2. That is going to correspond to a y value of 4.0401. And then we're going to take a second point, let's just call it Q prime, on the other side of 2. So the other side of 2 would be 1.99. That is another number that is very, very close to 2. Corresponding y value is 3.9601. Now, in fact, the closer the Q is to the P, the better the slope of the secant line will be in order to estimate the slope of the curve at point P. To find the instantaneous rate of change, then, you're going to pick a point Q on either side of P that's very close to P and find the slopes of these secants. It should be very close to the same value or rate of change, and then we can use this to estimate the slope of the tangent. Continuing from this example here then, to find our instantaneous rate of change, we're going to take the difference in the y values, 4.0401 minus 3.9601, and divide that by 2.01 minus 1.99. And that is going to give us our rate of change, which you can calculate should be very, very close to what the actual instantaneous rate of change is. Be careful. Do not round off too soon. Don't round too soon, or else you won't get a very accurate estimation of the instantaneous rate of change.